Today, I would be reacting magnesium, which is an active metal, with some hydrochloric acid, which is a mineral acid. For this demonstration, you can use any other active metal like aluminium or zinc, and you can also use any other dilute mineral acid like sulfuric acid, etc. But make a note that you don't use nitric acid because nitric acid the oxidation nature of nitric acid predominates. All that you need for this demonstration is some magnesium. Here I have some good magnesium ribbon and some dilute hydrochloric acid. All that would be happening in this reaction is that magnesium would react with hydrochloric acid to give us magnesium chloride and hydrogen. Hydrogen being a gas evolves out of the test tube, and you need some test tubes and a dropper. I've already taken some hydrochloric acid into this test tube, and one thing I want you guys to notice or note here is that when the hydrogen gas evolves, I would hold a burning splinter at the mouth of the test tube, and I request you all to notice the pop sound which would be produced very carefully. So first of all, I would take a piece of magnesium ribbon and I would add some to this test tube. Make sure you put your goggles on because this hydrochloric acid is very corrosive, and if it splashes onto your eyes, that day would not be very good for you. So you can see there's a good effervescence too, and I would be holding a burning splinter at the mouth of the test tube. Notice the pop sound. Did you notice the pop sound? I'll try to do it again. For those of you who did not notice this pop sound, the test tube has turned very hot, this reaction being very exothermic. Please notice the pop sound. This time it was very clear. And I would attempt to give an explanation as to why you hear a pop sound. All that you need to know to understand this explanation is the Dalton's law of effusion. According to Dalton's law of effusion, the rate of effusion is inversely proportional to root over the density of the gas. As we know that density is directly proportional to molecular mass of the gas, we can say that rate of effusion is inversely proportional to root over molecular mass of the gas. And as we know that molecular mass is directly proportional to the vapor density of the gas, we can also say that the rate of effusion is inversely proportional to root over the vapor density of the gas. As we all know, the lightest gas or the gas with the least molecular mass is hydrogen, which is whose molecular mass is 2. The next lightest gas being helium, the molecular mass of it is 4. So hydrogen is the lightest gas known to us. So here, once this term down here, the numerical value of this term down here decreases, we can see that the numerical value of this term over here increases. So molecular mass being the least, the rate of effusion of hydrogen gas is the most. And as soon as the hydrogen gas is produced over here, it makes its way very fast out of the test tube, making an envelope around the burning flame of the splinter and ensuring that the connection of the flame with the atmospheric oxygen there is no more connection of the flame with atmospheric oxygen, and hydrogen being a non-supporter of combustion does not allow the flame to burn, and once they link with the a supporter of combustion, which is the atmospheric oxygen is cut, the flame is once put off. And this formation of envelope is so quick that the flame is put off. When the flame is put off, the heat energy must be transferred into any other form of energy as per law of conservation of energy. This formation of envelope is so quick that the heat energy of the flame is converted into sound energy, and the sound energy is in the form of sound waves, which are in the frequency range of 20 hertz to 20,000 hertz, which is the audible frequency range of human ear. Thus, a pop sound is heard, and the reason why there's no other form of energy which is produced is that heat energy is not produced because air being a poor conductor or a very good insulator of heat, the heat energy produced can't propagate and it is now constrained at that region only, and and electrical energy is also not produced because air is very poor conductor of electricity, so there's no electrical energy produced too, and there's no mechanical energy produced. Mechanical energy in the sense that once I put the sprinter onto the test tube, this the gas does not pushes this sprinter away from the mouth of the test tube, because the force with which the gas hits the sprinter is very less, so there's no movement of the sprinter too, so there's no mechanical energy produced also. So here the best form of energy which would be produced is only the sound energy, because air being a medium through which sound can travel, it's very easy for the sound to propagate. And if you guys had noticed that once you had heard the pop sound, the sprinter just went out for very instantaneously, and the sprinter just lit back again very quickly. This was because the hydrocarbons which were burning in the sprinter were still alight, though the flame was put off. And once the sprinter was put off, the atmospheric oxygen rushed into the region back and lighting up the sprinter again. So this was my theory of why you hear a pop sound when a sprinter is put off. When a sprinter is put off by hydrogen gas. So if you don't agree to this theory, you can always question me in the comment section down below. And I forgot to tell you that this pop sound test is also the traditional or classical test to notice the presence of or identify the presence of hydrogen gas. And that's all from my side in this video. Thanks for watching, and I repeat again that if you don't agree with this theory, you're always free to make your comments and question me down in the comment section below. I would as soon as possible I would reply to your comments. So that's all from my side in this video. Thanks for watching, and please do like, share, comment, and subscribe. And I also have a Patreon page. If you guys like my videos of chemistry and science, you can donate $1 or so to my Patreon page, for which I would provide a link down below. Thanks for watching.